And again, welcome to today's webinar, Introducing Amazon Kinesis. Our presenter is Adi Krishnan, Senior Product Manager with Amazon Web Services. Adi, you have the floor.
Thank you. Hello, everybody, and thank you for taking the time out and learning a little bit more about our new service, Amazon Kinesis. In the next few minutes, we are going to talk about a few different things related to continuous real-time processing. And hopefully you'll get a flavor for what customers are doing today with this space that's being referred to as streaming data processing. We'll talk about different customer scenarios and use cases, as well as current approaches that customers are taking to help address some of the issues that are coming with streaming data processing. We will then talk in detail about Amazon Kinesis, what the service is, its capabilities, what does it mean to put data into a service like Kinesis, what does it mean to get data from Kinesis streams and building applications that can perform continuous processing on the streaming data. And finally, we will talk about how customers are using Kinesis today and bring continuous real-time processing into their businesses. And we will wrap up in talking about how Kinesis can operate with a variety of other systems, including other data stores and other processing engines such as Storm and even Elastic MapReduce. Let's spend a little bit of time talking about the motivation for continuous processing of streaming big data. No one will dispute the fact that there is unconstrained data growth. And this data is being driven by a variety of different portions of our infrastructure and of our customers' infrastructure. But the key thing that is changing now is how the data life cycle is demanding of more frequent continuous understanding, and how this continuous understanding is required of the data as early as it's produced. Let's walk through a few examples. For anyone managing any reasonable sort of IT infrastructure, we notice logs being continuously generated from that IT application infrastructure. This includes metering logs, audit logs, change logs, logs that we have all dealt with in some shape or form. In majority of cases, most of this, if not all of this log data, it remains housed or buffered on the very device or host where it is actually produced. And it does so for a long time before we decide to bring it in for any kind of analytics. Then there are other kinds of data producers or sources of data where there is some more urgency in collecting, interacting, and then analyzing that data. Some examples of this include the websites that we run that ultimately customers then engage with, mobile apps, advertisements. All of these assets generate click streams of data where there is inherent value in capturing, storing, and analyzing as quickly as it's produced. Then there are examples of data sources that are continuing to grow where data is being produced continuously in an infinite form, and in many cases by machines themselves. Examples of these categories include social media data and sensor data that is emanating from a wide variety of sensors, ranging from the weather grid down to our wearables. In these cases, it is easier to understand why there is immediate value in capturing and analyzing that data. But the key change that is happening in the industry is one around capturing, storing, and analyzing data as quickly as it's produced. Let's look at a very typical data flow that happens in the industry. There are sources of data, clients, sensors, servers, hosts. Let's call them producers in a more general fashion. The data produced by these devices and sensors and hosts ultimately needs to be aggregated as a first step. Once that data is aggregated at some coarse-grained granularity, it then needs to be processed. There could be many different kinds of processing. A typical kind of processing is a more pre-processed variety, where the data is being aggregated and some simple statistics or simple metrics are generated of that data. Invariably, data in that form, raw or pre-processed, ends up being stored on a longer-term basis, onto which a variety of different analytics and reporting tools are then applied to draw out business-specific insights. There are a whole variety of different technologies, different solutions at varying stages of evolution that are in play here. Customers typically compose and aggregate these solutions together to move their infrastructures to a stage where instead of building a whole lot of state, creating and holding a lot of data on the original source itself, the movement becomes one of getting that data into these aggregation systems and expose them for continuous processing. While the logo map down there in the picture has a lot of different technologies, it's by no means complete. And there will be several other solutions that exist today and will continue to be built to help customers along this journey of capturing that data to ultimately analyzing it. But let's get a little bit more specific. What would customers want to do with the ability to do streaming data ingestion and processing? We see three kinds of scenarios emerge across a variety of different industry segments. The very first scenario happens to be not very glamorous at all, but a scenario that has tremendous value for lots of businesses and customers. And this is around accelerating the pace of data ingestion coming from all of these different sources of interest. Please bear in mind that the actual data types can be various and many. As we discussed, this could be IT infrastructure, application logs, this could be social media feeds, this could be financial market data, data emanating from customer website clickstreams, and it could include sensor device data inclusive of geo and location data. But regardless of the data type, the first scenario is to have a system that enables this continuous ingestion of data as quickly as it gets produced, so that the producer doesn't have to worry about storing, buffering, and maintaining state of that data. And that data is now durably persisted in a service or a system that can scale reliably and durably persist that data. Specific examples here include ingestion, capturing, and storing of IT server application logs. In the broader digital ad tech marketing space, this could be valuable advertiser and consumer interaction data. In the financial services space, this could refer to transactional order data for trades that are being executed in the marketplace. In the broader consumer online space, this could be customer engagement data with those assets where there is a desire to capture and transform and load that data into a durable system as quickly as possible. The second big scenario builds on top of the first one. Once this data is being ingested, there is the need to continually generate metrics and key performance indicators from that data. Using the examples from before, a software or a technology infrastructure would want to generate operational metrics and drive a dashboard for how is my IT infrastructure performing right now. A digital ad tech company would desire the ability to generate real-time metrics like ad coverage, impressions, click-through rates, yield rates, and to get those metrics in a continuous real-time fashion as quickly as those end customer interactions are happening with those advertisements. In the financial services space, there would be a desire to create these metrics related to actual trades being executed in the marketplace, and to do so in a continuous new real-time fashion. In the consumer online space, the same data that has been aggregated and ingested will be transformed to extract metrics like how many page views, how many visitors, how many click-throughs, how many clicks did a given website component get. And along this customer journey of what one might do with this streaming data comes a third category of scenarios, which is really the notion of more responsive analytics on that streaming data. Some examples here include generating analytics on user engagements with ads. This would be in the broader digital marketing space. In the financial services sector, this might mean things like auditing off-the-market order data, doing fraud monitoring, and applying more complex computations such as value at risk assessment. In the consumer online space, this category of a scenario would include things like doing complex clickstream analytics, understanding the next best click, or to drive a recommendation system that can provide to the customer options that would ultimately drive further engagement with the consumer online asset. So we see this graduated model of how a variety of scenarios are being applied to a broader space of continuous streaming data ingestion and processing. Let's get even more specific. So what are some examples of how customers are going to use streaming big data processing in action? The first example is that of a mobile social-based gaming company. The company desires to deliver continuous game insights data that is being generated across hundreds of game servers. The solution in place today is an in-house custom-built solution that is operationally complex to manage and not scalable, and definitely much harder to scale in an elastic real-time fashion. The downsides with this current approach are as follows. There is a delay in critical business data delivery. So what was the gamer's engagement with any inside of the game? What was the critical metric for how gamers were engaging with any given game? The second downside is the overall burden in operating, building, and scaling a reliable platform to accomplish this ingestion and processing of data. And finally, the big business impact is that there is a slowdown of customer insights. Customer insights that when gained readily and in a continuous fashion can help evolve product strategy and can help evolve business strategy and ultimately impact the company's top line. So the fundamental desire with a system like Kinesis would be to accelerate the time to market of these real-time applications while minimizing operational overhead. Let's take another example, one in digital advertising tech. The desire here is the ability to generate these real-time advertisement metrics and KPIs for gauging ad performance for both advertisers who buy these ads and for publishers who end up displaying these ads. The solution today comprised of a big fleet of store and forward servers that would hold these logs, create an intermediate level of durability and persistence before emitting that data into a bigger Hadoop-based processing pipeline. The drawbacks of operating such a pipeline are threefold. The first is that sometimes the store and forward layer isn't very reliable, so there is lost data. There is ongoing operational burden in managing this overall pipeline end-to-end in a reliable, scalable fashion. And then finally, even if it runs on an optimal manner, the pipeline is fundamentally batch-oriented, which means that getting to a more continuous real-time sense of customer insights will be much harder. And the business desire and the outcome with a service like Kinesis is to generate the freshest analytics on advertiser performance so that the company can revert to the advertiser to give them the fresh, latest analytics so that marketing spend can be optimized and overall responsiveness to the client can be increased. So what are some other typical solution sets in which this sort of a streaming data processing system is being constructed, operated, and managed today? We see three big categories. The first category has composed together solutions comprising of focused data ingestion software components, examples here being Kafka, Flume, Kestrel, Scribe, or other message queuing products, and then coupling such a system with a focused streaming data processing engine such as Storm. Another bigger category of customers are cobbling together their own do-it-yourself AWS-based solutions. An example of such a composed solution would typically include a fleet of EC2 servers as logging or pass-through servers that ultimately emit data into an S3 store, followed by a subsequent EMR workflow to extract the data from S3 to ultimately compute business relevant metrics. There is a third set, and that third set is still exploring how do we move from a more batch-oriented way of producing data to ultimately consuming it, a process that might take hours or days even to produce insights, to a capability where there can be a continuous ingestion of valuable data, producing real-time insights on that data. Whenever such a solution is composed together, there are always some considerations that need to be bear in mind. While there are many specific considerations, the few that I would drill down on are the notion of ongoing operational complexity. Once the solution has been cobbled together and it's running, what does it mean to manage that system on an end-to-end basis continuously? The second consideration that I would emphasize is what is the developer and IT operations overhead, the time and energy expended to manage and run that system. And the third consideration I would emphasize is what does it mean to scalably, elastically grow such a service to be responsive to the needs of the business while not costing an arm and a leg. In looking through all of the different customer use cases, the various different approaches that customers are using to build these capabilities today, we arrive at this foundational basis for a streaming data ingestion service that enables continuous processing. And the way Amazon Web Services thinks about it is in a relatively practical or pragmatic right tool set for the right job approach. To enable this continuous stream processing approach, then, one would need two components. The first component enables real-time ingestion of data. This component needs to be highly scalable. It is the first line of defense when it comes to durability of important business critical data that is being emitted into it. This ingestion capability would be elastic, so at any point in time, the customer should be able to scale up or scale down without stopping or pausing operations of any kind. And this ingestion storage mechanism should be able to support replay of older data. The second component of such a service would enable continuous processing of the data that has been ingested in the first place. This processing framework would enable a load balancing of incoming streams of data, which could be time varying. The processing framework would enable a fault-tolerant approach to continuous processing and enable abilities like checkpointing and replaying. And this layer would be elastic as well. Elastic to respond to incoming data streams and scale up or scale down accordingly to preserve the overall latencies of processing. These two components come together to ultimately enable continuous real-time workloads across a variety of scenarios across industry segments, as we discussed earlier. Not only that, this foundation would also be a managed service delivering a lower end-to-end latency from the moment data is put into the system through the ingestion substrate to the moment it gets exposed for different kinds of processing. And as another fundamental attribute, this service would be able to move data into multiple different kinds of data stores and processing engines for subsequent processing. So what then does Amazon Kinesis provide to help real-time streaming data ingestion and processing? Now imagine a system where you can put data from a variety of different data sources, be it on-premise servers, EC2 instances running portions of the application stack, mobile devices, smartphone sensors, as long as they can do a put, the ability to do a put that gets captured reliably, stored durably, replicated across availability zones by default, and then exposed for processing to multiple different applications that you can author, develop, and run. So Amazon Kinesis then is this managed service for real-time big data ingestion that enables continuous processing. In this diagram, we see data coming in from a variety of different sources. In your specific use cases, it could be IT infrastructure logs. It could be your mobile gaming application running on a smartphone. It could be data that is put into Kinesis from a web browser directly. And Kinesis will reliably, scalably, and durably persist that data as it's put into it and then expose it into your processing instances. And you can imagine having multiple different kinds of applications processing the same big stream of data. One application could be simply deduplicating and aggregating the data before emitting it into a store such as S3. Another application could be extracting key metrics and driving a real-time dashboard, leveraging a service such as DynamoDB. Another application could be running, let's say, a 5-minute sliding window analysis on that data and then emitting that into a large-scale data warehouse like Redshift. And you could have yet another application that takes in this big stream of data, filters it, and then generates a new Kinesis stream. That, in a nutshell, is the capability of Amazon Kinesis. And we will now get into specific details of what does it mean to have a stream, how do we put data, and how do we read data from Kinesis and build applications. The foundational concept in Kinesis is one of a stream. And a stream is a named entity that a customer controls, which provides them with the ability to capture and store data. A stream is composed of units of scale called shards. Each shard provides a data ingestion rate of 1 megabyte per second and up to 1,000 writes per second for one shard. Every shard can emit data to enable processing at up to 2 megabytes per second. Therefore, when you build a stream in Kinesis, you would simply request the server to create a stream with n shards. So if you want a stream that can capture and store 10 megabytes per second of data, you would simply tell Kinesis, give me 10 shards in the stream. And in real time, the stream will spin up, giving you effectively the 10 megabyte per second in and 20 megabyte per second out capacity. A key attribute of Kinesis and Kinesis streams is that they serve as excellent large-scale sequential write followed by sequential read patterns. And because Kinesis is a strongly consistent, durable store, and the processing pattern that it enables is one of continuous processing of data, all data inside of a stream, and therefore in any given shard, is stored for 24 hours. Inside of that 24-hour window, data can be replayed. A cursor can be called by the application to move it back in time to the oldest data and then read from that data. Kinesis is also highly scalable, and one does that by adding or removing shards and Kinesis responding in real time and adding shards into the stream or removing shards from the stream while the stream is in operation. Therefore, the operational complexity and burden of stopping the infrastructure, scaling it up, pausing business operations, and then picking that back up is done away with the Kinesis stream. Now that we know what a stream is conceptually, how does one put data into Kinesis? Kinesis enables that by producing a simple put interface. Producers, as we learned before, could be any device, any host that can make effectively an HTTP put call. The put record interface requires 3 parameters. The actual blob of data that needs to be put into Kinesis, the name of the stream to which the data is directed, and a partition key that is supplied by the developer, by the architect, and that the producer would include as part of the put record call. The partition key exists to distribute the puts across the shards in a stream. When the Kinesis service receives the put record call, it generates an MD5 hash of the partition key, which is mapped over a given hash key range of any shard. What this means is that if the scenario requires for data from a given producer to always be placed and captured inside of a specific shard, then supplying that partition key would guarantee that inside of the Kinesis stream. After the data is put into Kinesis, it gets three-way replicated across availability zones by default, and a unique sequence number is returned to the producer as a successful acknowledgement. The sequence number itself is a monotonically increasing number per record in the shard. In order to create a stream, the service makes it easier with the help of the console, wherein a stream can be created by simply supplying the stream name and specifying the number of shards. There is a simple calculator that will help you decide how many shards are how many shards might be relevant in your specific use case. And the shard calculator will help estimate on your behalf the number of shards that might be suitable for your use case in the stream. And in this manner, through a series of 5 clicks, you can create a fully functioning stream that can capture and store your streaming data in a reliable, scalable, and durable form. This is a little code snippet that shows what a put record call might look like. As you can see, it's an HTTP post. The put record call itself contains the example stream name, the data blob, and the customer supplied partition key. Kinesis itself treats all data as blobs. It does not inspect the data. The only piece of metadata that is returned is the sequence number on a per record in the shard basis. Let's switch sides now. We've learned about what the stream is, what is the unit of scaling, specifically the shard, and what does it mean to put data into the Kinesis stream using the partition key. Now, how about reading data from Kinesis streams and setting up to do continuous processing? Before we get into the details, there are some higher level attributes that we believe a continuous stream processing application embodies. The key attributes are as follows. This is going to be a long-running, permanent application. The incoming stream of data does not stop. It might change in volume, and which can be easily handled by Kinesis by having the customer increase or decrease the number of shards, but the processing application has to accordingly process that data. The second key attribute is that the application needs to be fault tolerant. Because data is being continuously ingested and exposed for processing, this application needs to handle any failures that might occur in itself as it's processing this data. Thirdly, the application itself needs to be distributed. The streams can become arbitrarily large in size, many megabytes per second, hundreds of megabytes per second. And the application has to be distributed to handle that scaling and change in stream capacity. And lastly, the application has to be elastic in nature. It should scale up or down accordingly as the shards in the stream increase or decrease, such that overall throughputs and latencies are maintained. For the Kinesis service, there are 3 ways in which data can be read and then exposed for processing. Option 1 is to leverage the GET APIs that the Kinesis stream exposes to read from the stream directly. The second approach is to build applications, business-specific applications, by leveraging the Kinesis client library. Another option is to use an existing processing engine, such as Storm, and use the Kinesis spout to read data off the Kinesis service. We will now talk about option number 2, which is how do we build continuous processing applications with Kinesis using the client library. Now, the Kinesis client library enables fault-tolerant, at least once, continuous processing of applications. It's a Java client library whose source is available on GitHub openly. In this process, the developer would first build a core business application. Now, this business application could be relatively simple or relatively complex. Let's take the case of simple aggregation and compression of data before sending it on its way to S3. So how does the Kinesis client library help in this regard? The application is built with the Kinesis client library and deployed on the developer's choice of EC2 instances. They retain complete control and flexibility on making the choice of what EC2 instances are going to be the best fit for their processing applications. The client library enables the developer to focus on building the business logic and serves as the intermediary between the business-specific logic and the stream itself on which the application is operating on. The client library automatically starts up a Kinesis worker for each shard in the stream. The application itself does not need to be aware of at any point how many shards there are in the stream. The client library does the heavy lifting of inspecting and querying the stream to understand how many shards there are. It instantiates workers and then starts assigning shards into those workers. In this way, it simplifies reading from the stream itself. Now, as the number of shards in a stream changes, and that can change because of any developer action, the client library will increase or decrease the number of workers running on the EC2 instance or sets of EC2 instances in response to that shard change. Additionally, the developer can configure checkpoints as part of the client library that it will maintain in a shard management table in the background to keep track of where any given worker was in processing a given shard. If a worker fails, it gets restarted and the data in the shard is replayed into that worker. The Kinesis client library can extend to auto-scaling groups. So as a developer, you could deploy this application on multiple instances of EC2 running under the aegis of an auto-scaling group, and the client library will redistribute workers as new instances get spun up or spun down. This is a little code snippet that goes to show what it means to implement the iRecord processor factory, which is the interface responsible for integrating Kinesis client library and your application code. As you can see here, you can checkpoint, you can determine your checkpoint interval, and the client library will maintain that state on your behalf. This is a very simple example of what a sample worker might look like that you instantiate to ultimately process your stream. The key thing is that the application developer does not have to worry about the lower-level distributed systems processing involved in processing continuous changing streams. There are two more options to read from Kinesis streams. As mentioned earlier, the raw GET APIs can be used, GET records and GET shard iterator being the two most important APIs for reading data. And the Kinesis service also supplies a Kinesis spout for Storm in an open source manner that enables customers to use their existing Storm topologies and read data from Kinesis streams. This spout helps bootstrap data using the Zookeeper installation as part of the Storm topology. It fetches data from the Kinesis stream, emits tuples in a form that the Storm topology can understand, and drives checkpoints using the customer's Zookeeper infrastructure as part of the Storm topology. As we mentioned, Kinesis also enables movement of data across different other processing systems and data stores. The Kinesis connector library is a customizable open source set of applications that help connect Kinesis streams via Kinesis applications onto stores like S3, DynamoDB, and Redshift. Customers can define and override the classes present, such as the transformer class, a filter class that helps exclude records from processing, a buffer class that can specify the limit of number of records or total bytes to be buffered before emitting using the iEmitter class onto systems like S3, Dynamo, and Redshift. So let's come back and revisit our original customers and see how they could use Amazon Kinesis in action. As a refresh, we have the mobile and social gaming customer who wants to deliver continuous real-time gaming insights across hundreds of game servers. And we have the digital advertising tech pioneer who wants to generate real-time metrics for advertisers and publishers for the performance of online ads. Let's look at the gaming analytics with Amazon Kinesis. Imagine, if you will, clickstream data coming from all the servers that host the actual gaming infrastructure, putting data into Kinesis. One Kinesis application is processing these gaming clicks happening inside of a given customer's online game. A clickstream processing application is generating real-time metrics on the data as it is being driven in. This application, like all Kinesis applications, is written by the developer. And then that data can be emitted onto a dashboard. Another Kinesis application is simultaneously creating aggregate statistics of these interactions and then emitting that data into a store like S3, from where it can be populated into Redshift for business intelligence users. And at the same time, there is another Kinesis application that is just archiving all the data so that it can then be used downstream for historical analysis with Hadoop-style systems. Here's a second example, the digital ad tech company who implements metering systems with Amazon Kinesis. Ad engagement data across browsers, across clients, across hosts is emitted as a Kinesis stream. One set of Kinesis workers continuously extract ad metrics and display them onto a dashboard. Another set of another Kinesis application generates incremental statistics of the ads. So these statistics can be deployed, can be emitted into Redshift, so that now a wider pool of end customers can gain access via SQL-style querying. But Redshift now contains fresher data than before. And then, like before, another canonical application stage is merely compressing and archiving all the data for later analysis. These customers have been able to experience an easy-to-use managed service for ingesting all of their data of interest in real time, and then with their flexibility and control are able to deploy their applications on their choice of infrastructure, including using existing services, using existing software solutions like Storm or even EMR to process that data. And they've been able to do that with Kinesis' simplified pricing model that is pay-as-you-go without any upfront costs. There are two dimensions to Kinesis: the hourly shard rate, shards that customers can control. They can add or remove at any point, where each shard delivers 1 megabyte per second on ingest and 2 megabytes per second on egress. All inbound data transfer into Kinesis is free of charge. The second pricing dimension is every single put call, but it's priced incredibly low at a cost of under 3 cents for 1 million put transactions. Because customers control the EC2 instances on where their applications run, those are typically separate charges that apply. Just a quick summary now of what we've learned about Amazon Kinesis top benefits. First and foremost, it is really easy to get started with a real-time streaming data collection service that enables real-time processing. The service helps move big data processing from minutes or hours of end-to-end latency to one of a few seconds. It is high throughput and elastic, where customers, developers, and architects can control that throughput and elasticity. Kinesis allows building of real-time applications through first-party assets like the client library, and also by enabling integration with other solutions like Storm. And finally, Kinesis is a low-cost way for workloads to ingest workloads of any scale. Now, as we wrap up and open up for Q&A, we would love for you to trial Amazon Kinesis, come through our documentation guide, visit and post on our forum that already has an incredible wealth of information generated on it. And we would love to continue the conversation with you on Twitter at my handle mentioned below.
Cool. Well, thank you, Adi. In your browser, you will see a poll pod appear. If you could take a few moments and answer our 5 quick questions, we will then run into Q&A. First question, do you currently use or plan to use Kafka or some other system for performing continuous ingestion of data? Thank you for that. Next question. What do you currently use or plan to use for performing continuous, real-time processing of data? Our next question is, what is the topic you would like to learn next? Thank you again. Our next question, how effective was the presenter in communicating the content today? Great. We're on the home stretch here. Our last question today is, overall, how satisfied are you with today's webinar? Well, thank you again. Your feedback is truly appreciated and will help us always better improve our webinar platform. We'll now start with the Q&A. Audie, what are some of the questions that the audience addressed today?
The questions that we have for us here span across details around shards, details around using a sequence number and how that plays into leveraging the system, several different kinds of questions around different support for languages platforms, and then a few different questions around how Kinesis compares to some very other specific products that exist in the marketplace. So we're going to start with a categories of questions around shards. So in general, the way to think about the shard is that it's a shard. When you put data into a shard with a partition key, it's actually getting mapped over a hash key range, which means that the concept of adding a shard into the system is really the concept of splitting a shard. In fact, the actual API that you call is called split shard. So what is happening is, in effect, your hash key range is now getting split. Similarly, when we talk about removing shards, a shard isn't being removed necessarily in the system. The actual operation that you would do is a merge shard, wherein the hash key range is now merged from two different shard IDs. Therefore, any concerns around does data get lost when a shard is merged or split are not in play, because what's really happening is that the service is simply morphing the overall hash key range so that you can continue to put data and read data, and the data is always preserved in the shard up to the 24-hour window. There is no explicit cleanup of messages that needs to happen from the shard. Secondly, what it means is that when we are reading from the shard, what's happening is that records, individual records, are being delivered as a big batch into the processing logic itself. And when you use the Kinesis client library, it will simply go ahead and fetch the next set of records by making the get records call. So in this way, the application of the developer, when they use the client library, do not need to necessarily explicitly specify where they need to read the shard from. Having said that, the shard iterator concept enables developers to explicitly specify where in the stream they want to place that cursor to begin reading the data records from. This movement is subject to the 24-hour storage retention period that Kinesis has for all streams in the data. So hopefully this addresses questions around splitting and merging shards, whether data ever gets lost because of that operation, whether it can happen in continuous real time, and is there any notion of cleaning up of messages from the shards and the notion of replaying data from a shard. So hopefully I've addressed a bunch of questions because I've on the fly categorized them as being shard related. Now let's move on to a set of questions around sequence number and ordering. So sequence numbers, as we discussed, are the way we signify a successful put inside of the Kinesis service. Records, as part of those put calls, are typically ordered within a shard. So explicit ordering within all the shards in the stream is not something that is provided by Kinesis by default. Specific ordering on put can be accomplished on a per partition key basis by implementing some logic on the producer side that uses the sequence number, the previous sequence number returned by a successful put call, and providing that as input for the subsequent put call. So that is a way in which a developer can leverage Kinesis to do a stricter ordering of the puts into the system. But please note that when we replay data from a processing side, we always replay data in the same order across different replays. Now there are a few different questions around the availability, or future availability of the Kinesis client library in languages such as Python and Ruby. And I also see a few different questions around the SDK availability across languages. I would like to provide some higher level clarification. In order to put data into Kinesis, that can be accomplished using the AWS SDK. And in any language that the SDK is available in, Kinesis is also available in from a putting data standpoint. When it comes to creating processing applications, Kinesis is today Java only, and we are actively collecting and assessing customer feedback on what the next set of languages, Python, Ruby, etc., that we should prioritize in order to deliver a more native functionality in. The next question or set of questions that I'm going to look to tackle is the notion of how does Kinesis compare to other similar products, and a few examples that I see here are Stream Insight from Microsoft, InfoSphere Streams from IBM. Those are two that I see immediately pop up, and I'm going to provide a very top-level answer to that. Kinesis is a fully managed service that runs on the AWS cloud. It's not driven by databases. It is a low-cost, highly scalable service. Developers and architects it's targeted towards developers and architects who are going to be putting data across any sort of device and then writing applications that do continuous processing with Kinesis. So in that sense, the delivery model, the pricing model, and the application processing paradigm for Kinesis are quite different from some of the other alternatives that were called out in the questions.